Today, the 10th week, we are going to look at multiple linear regression. In multiple linear regression, you remember last week, simple linear regression, there was only one independent variable. But in the multiple linear regression, we have two or more independent variables. So we have x1, x2, up to sk, and the random error term, and one dependent variable, which is y. So we have more than one independent variables predicting y. Okay, so that is what we refer to as multiple linear regression. The beta 1, beta 2, up to beta k are the slopes, and the alpha is the intercept on the y-axis. And epsilon here is a random error term. Okay, so that is what we are going to look at today. And as I told you last week, whenever you have a cap on top of the parameters or the coefficient, then we refer to them as estimates. So the cap simply means estimate of the actual values which are not known. So what we are going to do today is how we can estimate these values. And the independent variables are two. So what determines sales are two variables. And because there are two variables, it's no more a simple linear regression, but it's a multiple linear regression. So it's a price and advertising that affects sales. Price and advertising. So suppose we collect a sample of size 15 weeks to determine the relationship between sales, the sales of pi, and the two independent variables. We may call it x1 and x2. So that's what you are doing. So this is the data that is obtained from the field. So we have a sample of size 15. What is the dependent variable here? We have 5 weeks, which is a sample size. So we have a sample of size 15. Then these are the pi sales, the sales of pi. And that which is a dependent variable, which we normally denote by the letter y. Then we have the price of pi, which we are denoting by x1 in our model. And we have the effect of advertising on sales of pi, which we are denoting by x2 in our model. So the model is given by y equals to alpha plus beta 1, x1, and beta 2, x2, where x1 is price of pi and x2 is advertising. And the dependent variable is sales. So it means sales is determined by two factors according to this model, price and advertising. And this is the data collected from the field. Good. So from this table, we can feed this table into Excel, and Excel will generate this data, this output. So this is the output from Excel. We have the multiple R, then we have the R squared, we have adjusted R, we have the standard error, we have observations, the observations are 15. Then we call this one, the second table here, we call it the analysis of variance table. We call it the analysis of variance table. Then we have the last table, which gives you the coefficient of price and advertising and the constant. So this is the first value here. So this last table, we have the coefficient of price. The coefficient of price is minus 24.97509. And the coefficient of advertising, that's a beta. You remember this formula. So we want to find alpha, beta 1, and beta 2. So from the Excel output, alpha is this. This is alpha. That's 306.52619. And beta 1 here, this one is equal to this one, price, the coefficient for price. Then beta 2 is a coefficient for advertising. This beta 2 is a coefficient of advertising. So in essence, when you are asked to write down the regression equation, we just pick this plus minus 24.9 0.7509 times the price, or we can use x1 to denote price, or you can write price in ways. So we can write minus 24.975 x1 plus 74.131 x2, where x2 denotes advertising. So that will be, and this one is a y. We can also denote the sales is denoted by y in our model. So if you don't want to denote them by any letters, then you can write the actual names of the variables in your model. So this is our linear model connecting the independent variables price and advertising to sales. So sales is affecting price. Sales is being affected by two factors, that is price and what? Advertising. And these are the coefficients and can be quoted from the Excel output. And in this type of question, usually the output is given. Some aspects are omitted and you are supposed to compute them. That is all. So you are not supposed to do the hard computations to determine these values like we did in the simple linear regression. So these are the coefficients. So as we move, I'll tell you what this one means. So let's move to the next slide. So we can write a fitted regression model as y, when you are using y instead of using price and advertising. So y is sales. So this is a fitted regression model that we wish to determine. Okay, good. So what are the interpretations of the coefficients? So we are going to look at the interpretations of the coefficient. It means when price is 0 and there's no advertising, the average sales will be what? 306.526. So that's the interpretation of this constant term. Please, are we okay?
Yes, sir.
Good. And what is the interpretation of the beta 1? So this is a beta. Beta 1 is minus 24.974. What's the interpretation of beta 1? So interpretation of beta 1 is that all things being equal, when you increase price by 1 unit, the corresponding decrease in sales. If our price is inversely related to sales because of this negative, please, are you with me? Because of the negative in front of the 24.975, it means price has an inverse relationship with sales, and which is true in practice. When you increase price, sales is likely to decrease. That's the meaning. But advertising has a positive effect on sales. What it means is that when you increase the volume of advertising, sales is also likely to increase. That's the meaning of the negative and the positive here. Have you seen it? So for how do you practically interpret the minus 24.975? Please, are you listening? When price is increased by 1 unit, the corresponding decrease in sales will be 24.975 because price and sales are inversely related. So when price is increased by 1 unit, sales will decrease by about 25. Sales volume will decrease about 25. Yeah. Good. Because it is negative, the coefficient of price is negative. It means that there's an inverse relationship between price and sales. Inverse relationship means that when price increases, sales is likely to decrease. And when price decreases, sales is likely to increase, all things being equal. So there is an inverse relationship between price and sales. So what is the interpretation of this minus 24.975? The interpretation is this. The interpretation is that when you increase price by 1 unit, increasing price by 1 unit means that suppose the thing is selling, the pie is selling at, let's say, $1 or $2 and increase it to $3. We say there is a 1 unit increment. Have you seen it? So whenever price is increased by 1 unit, sales, is it expected to decrease or increase? When you increase price by 1 unit, do you expect sales to decrease or increase?
It will decrease.
It will decrease.
Why decrease?
Because
they are
price
inversely related.
Because of this negative, it means they are inversely
Related.
because of this negative, it means price and sales are inversely related. Okay, so in what way are they related? This is the interpretation. When price is increased by 1 unit, the corresponding decrease in sales will be 24.975. That's the interpretation. Have you seen it? Or you can say that when price is decreased by 1 unit, the corresponding increase in sales will be what? 24.975. Because you can use decrease or increase, but because they are inversely related, when price increase, sales will decrease. And when price decrease, sales will what? Increase. So the interpretation of this 24.975 is that when price is increased by 1 unit, the corresponding decrease in sales is 24.975. Or you can say that when price is decreased by 1 unit, the corresponding increase in sales will be what? 24.975. That's the interpretation. All things being equal. So we assume that advertising is fixed, everything is equal. When this one is varied by 1 unit, this one will also vary by 24.975. Okay, so what is the interpretation of the coefficient for advertising? What is the interpretation for the coefficient of advertising? So what is the interpretation of the 74.131? That's the coefficient of advertising. What it means is that all things being equal, is it directly or inversely related? Advertising and sales, is it directly or inversely related? I'm asking a question. Good, they are directly related. Why?
Because when you increase advertisement,
don't talk too much. It's directly because it's positive.
The coefficient is positive.
Because the coefficient is positive. So there's a direct relationship between advertising and sales. So the reason why it is direct relationship because of the positive coefficient of advertising. So what it means by positive coefficient, it means when advertising volume increases, it's likely sales will also increase. That's the meaning. And when advertising volume decreases, there's likely sales will also decrease. So advertising and sales always move in the same direction, but price and sales, they always move in the opposite direction. Okay, so how do you interpret the 74.131? What it means is that when advertising volume increased by 1 unit, the corresponding increase in sales is $74.131. So that's the meaning. When you increase advertising by 1 unit, sales is also likely to increase by 74.131 units. So that's the interpretation of the 74.131. That is the meaning. Okay. Or you know the reason why you use the $100 here?
No, sir.
Instead of saying 1 unit, it says what?
$100.
$100 because each unit is equivalent to 1 unit is equivalent to $100. The question, have you seen it? So these ones is in hundreds of dollars. Please, do you understand?
Yes.
Yes,
Yeah.
please.
So the advertising is in hundreds of dollars. So 3.3 means what? What does it mean? It means $330. Have you seen it? So three units means that $300. So it's in hundreds of dollars. So that's why we decide to use here instead of saying 1 unit. Have you seen it? Instead of saying 1 unit, you say what, $100, because 1 unit is equivalent to $100. Are we okay? Hear the question.
Yes, please.
Good. So you can say a unit increase in advertising, the corresponding increase in sales volume will be what? 74.131. So we use, like I told you last week, we normally use regression for predictive purposes, to predict. So suppose the price of a pie is $5.5 and the advertising volume, the cost of advertising is $350. They say you should predict the sales. We should predict the sales. So it means you put price to be equal to what? $5.5 and advertising to be what? 3.5. Why did we use 3.5? Because $350 is equivalent to 3.5 units per our question. So the sales volume, the predicted sales volume will be, when you substitute, use your calculator to calculate this, to give 428.62. So what it means is that when the pie is selling, each is selling at what? 5.5, and the advertising, the money spent on advertising is 350, then it's likely you are going to sell about what? 429 or 428 units of pie. So the predicted sales will be 428 approximately, or 429 approximately. The R squared, you remember we computed R squared in a simple linear regression. In the same way, you can also compute that. We call it a coefficient of determination. We call it a coefficient of determination, and it's SSR over SST. Good. So the SSR is a regression sum of squared, and the SST is a total sum of squares. So the regression sum of squared over the total sum of squared will give R squared. So how do you locate that on the table given? How do you locate that? So this is how you locate it. On the table, the Excel output. This is the Excel output, which will always be given to you in the exams. But whenever it's given, some of the values are omitted, and you are supposed to fill in the gaps. That's how the questions are framed. So when you look at the Excel output, the value here, which is named R squared, is the value of your coefficient of determination. Is the value of your coefficient of determination. So it's 0.52148 is the R squared. Or if it is not given, and this one is given, you square this R. When you square it, it will also give you what? 0.52148. When you square 0.72213, it will give you the R squared. Okay? But in case this one is not given, and this is also not given, the R squared also can be computed from the second table here. That is the SSR, the regression sum of squared, divided by the total sum of squared. So when you divide this figure by this figure, it will also give you the R squared. You can take your calculator and try it for me. So 29460.027 divided by 56493.33. So when you divide, what will be the answer?
0.521477.
Good. So that is the R squared. So if in case in exams, this value is omitted, you can square this and to give you the value. But in case the two are omitted, then you can get it from this table. This divided by this will also give you the R squared here. Okay, so we call it the coefficient of determination. And what interpretation did I give to the coefficient of determination? What it means is that, so what's the value? It's about 52.1. Is that not so? The coefficient of determination here is about 52.1. What are the two independent variables in our model? What are the two independent variables in our model? The price and advertising. And what is the dependent variable? So the dependent variable is volume of sales. Is that not so? Great. So the coefficient of determination, what's the value? The coefficient of determination here is 0.52148. In terms of percentage, it is what? 52.1%, about 52.1%. What it means is that sales and advertising are contributing about 52.1% to the prediction. No, sorry, price and advertising are contributing about 52.1% in the prediction of sales. Are you getting me? So the contribution of price and advertising in prediction of sales is about 52.1%. So it means other factors are contributing what percent? If price and advertising are together contributing about 52.1% of the total sales volume, what's the percentage contribution of other factors apart from price and advertising? So you subtract what? 52.1 from 100, and that will give us about 47.9. 47.9.
Yes, please.
Yes, please.
Great. What it means is that other factors apart from price and advertising are contributing about 47.9% to the total variation of sales. Okay, so that's the meaning, because it's not only sales, it's not only price and advertising that determines sales. But a customer relationship by those who are selling and all those things are all factors. But those factors are not captured in the model. For all other factors apart from sales, apart from price and advertising, are contributing about 47.9% to the total variation of sales. While the two main factors in the model, that is price and advertising, are contributing about 52.1% to the total variation of sales. So we move to testing the overall significance of the model. Testing the overall significance of the model. Whenever you come out with a regression model, this is a regression model, a multiple linear regression model, such as this. The next thing you do is to test the overall significance of the model. Because a model should be able to predict whatever you are predicting very well. And there's a way you can test the significance of your regression model. So that's what you are going to do right now. So when the test rejects that your model is not significant, then you throw it away. You stop the work you are doing. Maybe you look for other factors. It means price and advertising. What it means when it is rejected, it means price and advertising are not good factors in determining sales. So we are going to test the overall significance of the model, the overall. So we use what you call the F test. And I sent you what you call the F distribution table. I sent you the F distribution table. So we wish to test that, the overall significance of the model. we use what we call the F-test statistic. And the hypothesis to be tested is given by this H naught is beta 1 equal to beta 2 equal to beta k equal to 0. And H1 said at least one of the betas is not equal to 0. So this is the hypothesis for testing the overall significance of the model. In the example given above, there are only two betas. That's beta 1 and beta 2. So the hypothesis for the overall significance, the null hypothesis will be that beta 1 is equal to beta 2 and is equal to 0. And the alternative hypothesis is that at least one of the betas, that's beta 1 or beta 2, is not equal to 0. At least one of them is not equal to 0. So this is the hypothesis that we use to test the overall significance of the regression model you have determined. So using the above, so we test the significance of the multiple linear regression is a test to determine if there is any linear relationship between the response variable y, I get him, and the two regressors x1 and x2. In the example over there, the regressors are price and advertising. And the response variable, so y is also called the response variable. And the x's are called the regressors. Okay, so we have the regressor variables, which is x1 and x2 in the above example. And y is the response variable, or we also call it the dependent variables. Okay, so the hypothesis to be tested in the above is that beta 1, H0 says that beta 1 is equal to beta 2 is equal to 0. And H1 says that at least one of the betas is not equal to 0. At least one of the betas is not equal to 0. So either beta 1 is not equal to 0, or beta 2 is not equal to 0, or both are not equal to 0. That's the H1. So we reject the null hypothesis. When you reject H0, what does it mean? When you reject the null hypothesis, what does it mean? What it means is that the regression model is significant in predicting y. It means your regression model is significant. That's when you reject H0. So rejecting H0, rejecting the null hypothesis implies that at least one of the regressors x1 or x2 contributes significantly to the model. At least one of them contributes significantly to the model. But when H0 is retained, it means that your regression model is not significant. Then you have to stop and look for other variables that you can use to predict sales. Okay, so that is a test. We'll look at an example, and the test statistic we use is F equals to MSR over MSC. I'll show you from the table. And the degrees of freedom is K and N minus K minus 1 degrees of freedom. From the table, the degrees of freedom, is what? 2 and 12. So when you are giving the table, the 2 and the 12 here is the degrees of freedom. The F distribution has 2 degrees of freedom, the numerator and the denominator. So the numerator is 2 and the denominator is 12. So the degrees of freedom are 2 and 12. So we are going to use 2 and 12 degrees of freedom to determine our critical value in order to solve the problem. Please, can we move on?
Yes, sir.
Good. So the F-test statistic is this value in your table. When it is not given, so here you are not going to do any hard calculation. The F-test statistic, if this one is given, then that's your computation. Now, when you are doing the test of hypothesis, first you have a statement of hypothesis. Number 2, what do you have? you have the decision rule. Number 3, you have computation. The computation is what we are giving to you here, so you don't need to do, and you pick the values just from the table. So the computed value of f is this. And you also determine the critical value of f. When the computed value of f is greater than the critical value of f, then we reject h naught. Or when the p-value, we call this one p-value. When the p-value is very small, smaller than the alpha, then that will also lead to the rejection of h naught. So we'll look at an example as we move on, how to test for the overall significance of the model. So how do you test? In this case, what is the f value from the table? What is the f value from the table? It's 6.53861.
5, 3.
And what will be the critical value? The critical value is what you read on the F distribution table. Please, you have the F distribution table. Okay, so that's the F distribution table. What's the alpha? Alpha is 0.05. So always, we have alpha for one particular table, alpha for each table. So we are using alpha to equal to 0.05. And what are the degrees of freedom? The numerator was 2, and the denominator, the degrees of freedom, denominator was what? 12. So we have 2 and 12 degrees of freedom. So what will be the value? 3.89.
3.89.
0.89.
Yeah, 3.89. So the critical value for F is 3.89. So that's how I obtain the 3.89 here. This 3.89. So this is a computed value of F, and this is a critical value of F. Then we reject H naught whenever the computed value of F is greater than the critical value of F. So that's a decision rule. Reject H naught when the computed value of F is greater than the critical value of F. Then we reject it. So because 6.539 is greater than 3.89, we reject H naught. And we conclude that the regression model is significant. Okay, we conclude that the regression model is significant. Or we can say that because the p-value, where's the p-value? This one. Because the p-value here is smaller than 0.05, it will also lead to the rejection of H naught. So a small p-value leads to the rejection of H naught. So that is it. So you can also use the p-value when it is given in the table. You can use it to draw your conclusion. So when it is rejected, it may at least one of the regressors, that's X1 and X2, are contributing significantly to the prediction of Y. I get it. And what it also means is that we can conclude Y is linearly related to either X1 or X2 or both of them. So that is the interpretation. Then lastly, suppose the H naught is rejected. When H naught is rejected in our previous test, what does it mean? It means either sales, either price or advertising, or both of them are contributing significantly to the prediction of sales. Please, are you listening?
Yes, sir.
In our hypothesis, when H naught is rejected, this hypothesis, when H naught is rejected, what it means practically is that either price or what, advertising, or the two of them are contributing significantly to the prediction of what? Of sales. We can test the significance for each of the independent variables. So how many, for the example I give you, how many independent variables do you have? The example I just gave you about the pie sales. How many independent variables do you have?
Two.
So we have two independent variables. And what are they? What are the two independent variables? For the example I just gave you. What
Price
are
and
the
advertising.
advertising.
yeah, price and advertising. So what you do when we are building a model, so we are going to test each of them one by one. First, we test whether price is significant in predicting sales. And also we test whether advertising is significant in predicting sales. Are you getting me? So we test them one. So we use, in that case, we use what you call the t-test. So we are going to use a t-test to test each of them. So how do you do that? First of all, if you are testing for price, the coefficient of price is beta 1. Is that not so? So we say that H naught beta 1 is equal to 0. There's a no linear relationship between price and advertising. There is a H1 beta 1 not equal to 0. When you are testing for advertising, there is a H naught beta 2 because the coefficient of advertising is beta 2. So when you are testing for advertising, whether advertising is significant in predicting sales, then you do H naught beta 2 equal to 0 against H1 beta 2 not equal to 0. So that will be your hypothesis. And the test statistic that you use is beta 1 divided by the error term, beta 1 divided by the error term, which are all given in the table. I'll show you. The table, the Excel output, all these values are given. So you don't need to compute them, you just pick them from the table. And the degrees of freedom is also 12. The 12, how do you pick the 12? You also pick that one from the table. The table, this 12 for residual is the degrees of freedom for the test of significance of each of the independent variable. So the degrees of freedom is 12. So the T, you read the T, because it's a two-tailed test, you divide the alpha, which is 0.05 by 2, and that will give 0.025, and the degrees of freedom is 12. So when you read from the T distribution table, it gives you 2.179. So we reject H naught if T, the absolute value of T is greater than 2.179. So that will be the decision or retain otherwise. And what are the values of the T? For price, please, are you listening? For price, what's the value of the T statistic for price?
Negative 2.305.
Good. Then the value for T for advertising is 2.85478. So for advertising, what's the value of T is this? What's the absolute value for the T for advertising? Because it's a two-tailed test, you pick the absolute value. The absolute value will be what? 2.30565. That's the absolute value. So we say we should what? Reject when it is greater than 2.179. So this value, the absolute value, is it greater than 2.179? The absolute value is greater than, or it is less than?
It is less than. It is less than.
It's greater than.
We are taking the absolute value because it's a two-tailed test. So is it less than or greater than?
It's greater than.
So when it's greater than, we say we should what? Reject H naught. Okay, so here we reject H naught. Rejecting H naught means that price is contributing significantly to the prediction of sales. Have you seen it? Or we can say that because the p-value, okay, let's use this one. Because the p-value here is less than 0.05, we can also use a p-value. Because the p-value is small, that also means that we are rejecting H0, which means the price is contributing significantly to the prediction of what? Sales. What about advertising? The T statistic, is it greater than 2.179? It is greater than. Because it's greater than, for advertising, H0 to be rejected, which in advertising is also contributing significantly to the prediction of sales. Or we can say because the p-value here is less than 0.05, we can also conclude at 0.05 level of significance that advertising is contributing significantly to the prediction of sales. Okay, so that is the interpretation here.
The percentage yield Y from a chemical process is believed to be related to X1. The amount of ingredient A used, and to X2. The amount of solvent B used.
So what
We
it
wish to
means is
fit-
that, please, you wait a minute. The way you are reading, somebody may not get it. It means X1, you know the amount of what? Ingredient A used.
Yes.
And X2 denote what? The amount of solvent B
Solvent B.
used. So we have two predictor variables. That's the amount of ingredient A. That's our first predictor variable. And the second predictor variable is what? The amount of solvent B used. Have you seen it? So
Yes,
that
sir.
is the question. So we wish to fit the multiple linear regression model this to the following data. Okay, so the following, so don't worry about the data because the summary or the output is given. So you just have to use the summary to answer all the sub questions given. So the following is a summary of the output of the fitted multiple linear regression model to the data. So it was produced from Excel. So this is the output. And in the output, R square is omitted. So how do you obtain it? R square is omitted. How do you obtain it? The value of R squared. There are two
You
ways.
square
You square,
multiple R.
you square this one, and that will give you the value here. So square it and give me the answer. You square this value. What's the answer?
0.92044.
0.92044.
So the actual value here is 0. What? 920.
92044.
4. Okay, to 4 decimal places is it. But know that it's not given, so I'll remove it again. So along one of the questions you need to provide it and use to answer. You say the 10th question. So how do you interpret this one? It means that's about 92%. How do you interpret this? How do you interpret the 92.04%? Which is approximately 92%. What is our dependent variable from the question? What is our dependent, the percentage yield? That's Y. And we have two independent variables that are predicting percentage yield, which are what? X1, we denote what? Amount of ingredient A. And X2, we denote the amount of solvent B. Have you seen it? So these are the two independent variables. So when the coefficient of determination is 92%, what it means is that the two independent variables, the amount of A and the amount of B, are contributing about what? 92% in the prediction of Y. So the two independent variables are contributing about 92% in the prediction of Y. So what percentage is contributed by other factors apart from X1 and X2? What, about what? 8%. About 8%. So other factors are contributing about 8% to the total variation of Y. But we'll come to that. That's not what you're answering. So meanwhile, this one is not given. This value is not given in the question. So we'll go through the solution. So here too, the F value here is omitted, and the P value here is also omitted. Then when you come to the last table, one of the values here is omitted, and the two values here are also omitted. Okay, so we answer the question below. So what is A?
Write down the estimated model.
Write down what? The estimated model. To write down the estimated model, you need the coefficients. But unfortunately for us, one of them is not given, and we have to calculate it. We need to write down the model. Please, are you listening? You can write that statement. To write down the regression model, you use the coefficients to write down the regression model. But unfortunately for us, one of them is omitted. Which one is omitted? The amount of A, the coefficient, is omitted. So we need to calculate it. So how do you compute it? How do you compute it? Please look here, take your calculators. Are you taking your calculators?
Yes.
Good. Do this.
Yes, sir.
Please listen. Do this divided by this. What will be the answer? This value divided by this value. What's the answer?
$2.68285.
So it means this divided by this is this answer.
Yes, please.
So this row divided by this row give you the t-test statistic.
Okay.
Have you seen it? So when
Yes,
a value here is omitted, if you want to get it, what do? You do this divided by this, it will give you this. So suppose in essence, this one is omitted and you have to determine it. How do you determine it? You do this divided by this, it will be equal to this. Or suppose this one is omitted. You want to determine, how do you determine it? It will be this times this.
yeah.
Suppose this one is omitted in the question, exam question, and you want to determine the value, it will be this value times this value will give you this. So when you go to our exams question last year, please, are you with me?
Yes.
Yes, please.
How can you determine the omitted value here? Because we need
Apply
it to be what?
Standard error times T stats.
Good, good. Because this divided by this. Okay, try this for me. Multiply this by this. Multiply this by this and see whether you get 6.8991. Is it correct?
Yeah.
Is it correct? Good.
Yes, please.
So please, you listen. Whenever you multiply the standard error by the t-test statistic, it gives you the coefficient. So how do you determine the coefficient here, which is omitted? You multiply what? The standard error by
the T stat.
So what will be the value? Give it to me now.
7.8127.
7.8127.
8, 1, 2, 3.
Is it 3? Is it correct?
7.81.
3.
8.
It's 7.
It's 727.
Is it 27 or 23?
2, 7.
So this 3 is supposed to be 7.
7.
Please, are you okay?
Yes, sir.
Good. So since we have provided a coefficient here, we can easily write our model. What did I say? To write your model, you need the coefficient, but one is omitted. To determine the one which is omitted, you multiply the standard error by the t statistic, and that will give you the omitted one. So that's how I did this one. So the model is like this. X1 is a solvent A and X2 is amount of B. X1 is amount of A and X2 is amount of B. So the coefficient is the T statistic. Please, are you listening? Please, whenever you finish talking, kindly mute your mic. Whenever you want to talk, then you can unmute it so that you don't produce feedback in my recordings. This last one, if I catch you again, your life will never be the same. So can we continue? So the coefficient is a t-test statistic times the standard error. So when we multiply, what do you get? You get what? 7.8126. Is that what you give me? Is that what you gave me? 78127. I got here
27.
27. So this 6 is supposed to be what? 7. Is it correct? Like this. Okay.
Yes, sir.
Good. So what will be the regression model? It will be the first value. What's the first value here? 6.8991. That should be your first value. So this answer, let me pick it there so that you understand. So to write the model, it will be this value, okay, as your constant. Then what's the coefficient of the amount of A? Is 7 point what? 81. This is 7. Is that what you said? Is that what you said?
Yes, sir.
Good. So this will be 7.8127 x1, where x1 is amount of A. Then 1.6280 x2, which is the amount of B. So this is a regression model. Please, are we okay? So the regression model is given by this. Can we move on? So the regression model is given by this. So that answers question A. So you go to question B. What is the B saying?
Interpret the coefficients of the model.
Good. So we have to interpret the coefficient of the model. So this one, what does it mean? It means when there is no ingredient A and no solvent B, the average percentage yield is what? 6.8991. So that's the interpretation of the alpha. And what about beta 1? This is beta 1. What's the interpretation? It means the percentage yield will increase on the average by what? 7.8126 for each one what? What's this unit?
Ingredient in A.
One, is it grams?
Grams.
1 gram increase
Yeah, 1 gram.
in the amount of ingredient A. So every 1 unit increase of ingredient A, the corresponding increase in the percentage yield will be what? 7.8126. That's the meaning. And what's the interpretation of this coefficient? It means for every 1 unit increase in amount of ingredient B, the corresponding average increase in the percentage yield will be 1.6280. That is the interpretation. So that answers the B. So we go to C. What is a C?
Test at the 0.5 level the significance of the multiple linear regression model.
Good. So we are going to test the overall significance of the multiple linear regression model. That is a C. And that alone is 5 marks. That alone is 5 marks. So we are going to test the model. So what's the procedure? What's the test procedure I gave you? Number 1. Number 1 is what? Step 1, the statement of hypothesis. Step 2 is what? The decision rule. I've divided it for you. I just want you to remember those steps I gave to you. So the step 1 is a statement of hypothesis. Step 2 is a decision rule. Step 3 is a computation, which because of the table given, it is made easier. Then step 4 is the decision, and the step 5 is the interpretation. Please, are we okay? So what is the hypothesis? What is the hypothesis to be tested? So when you want to test the overall significance of your model, H naught, the H naught will be what? Beta 1 equals to beta 2 and is equal to 0. That's the H naught. And the H1 says that at least one of the betas is not equal to 0. At least one of the betas is not equal to 0. Either beta 1 is not equal to 0, or beta 2 is not equal to 0, or both of them are not equal to 0. And we are testing at the 0.05 level of significance. So that is a hypothesis to be tested. In fact, when beta 1, please, are you listening?
Yes, sir.
When
Yes,
beta
please.
1 and beta 2 are all equal to 0, or significantly not equal to, significantly not different from 0, then there is no model. So beta 1 and beta 2 should be significantly different from 0. So here we are testing the significance of the regression model. And the H now says that beta 1 equals to beta 2 and is equal to 0. Suppose there is a third factor, then it will be beta 1 equals to beta 2 equals to beta 3 and equal to 0. Suppose there is a fourth factor, then it will be what? Beta 1 equal to beta 2 equal to beta 3 equals to beta 4 and is equal to what? 0. But because the factors for this particular question is only 2, H naught is what? Beta 1 equals to beta 2 equal to 0. And H1 says that at least one of them is not equal to 0. At least one of the betas are not equal to 0. So we are testing at 0.05 level of significance. So now the decision rule. What's the decision rule? The decision rule, we need the degrees of freedom. So what will be the degrees of freedom for the F test? You go to the table, the summary table given, and you pick the first 2 values. You see degrees of freedom here. Please, can you see the F table?
Yes, sir.
This table is given to you in the exams. What are the degrees of freedom here? For regression, what's the degrees of freedom? 2. For residual, the degrees of freedom is 9. And for the total means 2 plus 9 is equal to 11. So the degrees of freedom here is 2, 2, and 9. The degrees of freedom here is 2 and 9. So the degrees of freedom you use to answer the C is 2 and 9, because we are going to use the F distribution table. So what will be the critical value? So please read from the F distribution table, F 0.05, 2, and 9 degrees of freedom. So you go to the F distribution table. We read what? 2 and what? 2 and 9 degrees of freedom. What will be the value?
4.26.
4.26.
4.26.
Good. So it is equal to 4.26. So that's the value. So that's how I obtain the 4.26 in over here as my critical value. So what will be the decision rule? The decision rule is that, so here there's not like 1 till test or 2 till test. The decision rule is that reject H naught when the computed F value is greater than 4.26, or retain H naught when it is less than 4.26. So this is the decision rule. So what is a computation? The computation is very simple. You go to the table, then you pick the F value. What is the F value? It is omitted. So how do you compute it? How do you compute the F value when it is omitted? Because we need it in the calculation. Who can tell me?
Sir, please, it is SS regression divided by SS residual.
SS,
Not the total,
SS.
rather.
Is it
No.
MS? Is it MS?
No, it
Please.
is the MS over MS residual.
So,
MS regression over MS residual.
So
That
it's-
is great. Okay, so let's move on. So how do you determine the F value here? Is the MS for regression divided by the
Divided by
MS for residual.
Yes,
MS
sir.
regression divided by MS residual. Okay, so let's go to our main slide and see whether it is correct. What is MS for regression here? This one. Please, what is MS for regression here?
14730.
Good. And what's the MS for residual is this. So how did we
225.
obtain? How did we obtain this F? It is this divided by, divide it and see. This divided by C, this. And check whether we'll get this value. This value divided by this value. What will be the answer?
Yes, sir, you get a 6.5.
Good. So whenever the F is omitted, which I'm sure will be the case in your impending exam, the F omitted, and you want to compute it, you divide the MS regression by the MS residual, and that will give it the computed F. Have you seen it? MS regression over MS residual will give you the computed F value. So let's go back to our question. Good. So what will be the value here? This divided by this will give us what? 384.0521 divided by 7.3783. What is the answer?
52.0515.
52.0515.
52.051
051.
to 3 decimal place.
Two.
It's okay.
No,
2. Okay, 2.
and we round it in.
Okay. So that's a value here. And we need value to this value to do, that's a computation. That's the computation I've done over here. So what is the what is the F value? Is MSR, that's the mean square for regression over the mean squared error. So this one is an error. So this is supposed to be E, mean square for regression divided by the mean square for error. Have you seen it? Error means residual. Residual is the same as error. So the mean square for regression divided by the mean square for the residual. And residual is also known as the error term. Please, are you following me? So when you divide the 384.0521 by the 73783, that will give 52.05 to 2 decimal places. I think over there we did it to 3 decimal places, but to 2 decimal places, 52.05. So 52.05, is it greater than 4.26 or less than 4.26?
It's greater.
It's greater. So should we
Yes, sir.
reject H0 or retain H0?
You reject.
Reject H0. Okay, so we
Yes.
come to the decision. Since 52.05 is greater than 4.26, we reject H0 at the 0.05 level of significance. So what is the interpretation? The interpretation carries 2 marks most of the time. What is the interpretation? It means at the 0.05 level of significance, we conclude that there is evidence that at least one of the independent variables affects what? The prediction of Y. At least amount of A, at least one of them. What are the independent variables? What are the independent variables in this question? Amount of A and amount of B.
Impedance A and
Have you seen it?
impedance B. Yeah.
So it means at least one of them is significantly predicting what? Is significantly predicting the Y, which is the dependent variable. So that is the interpretation. Or we can also conclude that Y is linearly related to either X1 or X2 or both. Either X1 or X2 or both. So it means the regression model is significant. Have you seen it? So we can say this. We can say this. I'm adding something to the write-up so that you understand better. At the 0.05 level of significance, we conclude that we can also write this. We what? We conclude that, where is the C? We conclude that the linear multiple regression model is what? Significant. Please, you get it?
Yes, sir.
Yes,
What,
sir.
what does it mean that the lean? It means that the model is significant. It means in your research work you're on the right path. But in case it is not rejected, then you stop the work. It means what you are doing is not working. It means those factors you are selecting are not predicting Y. So you just stop. You don't continue with the work. You choose another topic or you change the variables that you are using. That's when H0 is retained. It means you stop the work, you don't continue. You choose a topic, a different topic for your research work, or you change the variables that are affecting Y and see whether that will work, or you do another thing. You get it? Please, are we okay? So, or we can conclude that what? We can also say that at the 0.05 level of what? Significance, we conclude that at least one of the independent variable affects Y. That's the meaning. Or we can say that at the 0.05 level of what? Significance. Is it correct? Okay. We can also conclude that Y is linearly related to either X1 or X2 or both. So any of these conclusions is referring to the same thing. Have I made myself clear?
Yes, sir.
So we move to D. If it is clear, we move to D. What is D saying? Okay, so D is straightforward. It says predict a percentage yield in which the amount of ingredient A used is 2.6 grams and the amount of ingredient B used is what? Is what?
30.5 centimeter cube.
Yeah, 30.5 centimeter cube. So it means we are going to put X1 to be 2.6 and X2 to be 30.5 and predict the value of Y, that's all. So the D is what? So you put 2.6 in place of X1 and 30.5 in place of X2, then you compute. So that gives the answer for D to be 76.9 for the predicted value when X1 is 2.6 and X2 is 30.5. This are we okay? Then we go to 6E. What is 6E saying?
Test at 5% level of significance. H not B beta 2 is equal to 0
against
against H naught.
H1, this H1.
Okay.
Against H1, beta 2 not equal to 0, and interpret your results. Beta 2, what does it represent in our model?
Ingredient B.
Is a coefficient of ingredient B. So another way of stating this hypothesis is to test whether ingredient B is significant in predicting Y. That's another way of saying this. So test whether ingredient B is significant in predicting Y. So here we are testing only for ingredient B, whether it is significant in predicting Y. Please, you understand the question?
Yes, sir.
So we have two predictor variables, X1 and X2. And we have shown that the model is significant. So now you test each of them one by one, whether they are significant. But this time, the question says we should only do it for the ingredient, how do you call it? For the ingredient, for the B, for the X2. So we are going to test whether the X2 is significant in predicting Y. It could have been X1. That's when beta 1 is, here is beta 1. It means we are testing the significance of beta 1. So luckily, the hypothesis has been given to you already. So that's the step one. The step one is given by the question already. So where are we? So the step one is what? Statement of hypothesis, which is what? Beta 2 equal to 0 against beta 2 not equal to 0. This, are we okay? So what is the decision rule? Here we are using the t-test statistic. So what will be our degrees of freedom? You go to the table. The degrees of freedom of the error term is the degrees of freedom we are going to use for the t-test. What's the degrees of freedom for the error term, the residual? What the degrees
9.
of freedom for the residual is 9. So that's the degrees of freedom we are going to use in testing the significance of the x2, that's a beta 2. So the degrees of freedom is 9. And what is the alpha given? The alpha is 0.05. And because it's a two-tailed test, we divide 0.05 by 2, and that will give us what? 0.025. So you read from the t distribution table. What do you read? You read what? T 0.025 and 9 degrees of freedom. And when you read from the t distribution table, that will give us 2.262. 2.262. So what is the decision rule? The decision rule is that reject H naught when the absolute value of T is greater than what? 2.262, or retain H naught when it is less than 2.262. So this will be greater or equal to this. So what's it? Reject H naught if what? Let's make it simple. Reject H naught if this is less than this, or what? Given the alternative. Please give me the alternative, or what? Or retain H naught.
Accept.
Retain, oh, not accept. Retain H naught if what? If who is talking? If this one is less than
2.262.
so you can write it this way, like the way we've been doing it. Reject when it is greater than, or retain when it is what? Less than. So that will be the decision rule. So what will be the computation?
Hello, sir,
What?
please.
Yes.
Sir, please, can you please go over why you got the degree of freedom 9? I'm not getting it right.
Go. So go to the question. Do you have the question? Let me show it
Yes,
to
sir.
you. The degree of freedom for the t-test. What are the degrees of freedom here? We have 2, 9, 11. When you are
Yes.
doing the F-test have 2 degrees of freedom. That's why you pick 2 and 9. But this one
Yes,
is
sir.
t-test. So the degrees of freedom is just the middle one. What the degrees of freedom of the middle one is the 9 here. Have you seen it?
So, sir, please, it's always the middle one.
It's always the middle one for the t-test. But for the
Okay.
F-test, please, are you listening?
It's 2.
For the
Yes, sir.
F-test, the degrees of freedom are 2. You pick the numerator to be 2 and the denominator to be 9. But for the t-test, the degrees of freedom is only 1, which is the 9. That's the middle one. This one.
Okay, sir.
The degrees of freedom is 9. So you pick it from the table. You don't do any calculation. You just pick it from the table given.
Okay.
So the degrees of freedom is 9. So you read what? Why is this place 0.025? Because it's a two-tailed test. So you divide the alpha by 2 for the t-test. For the f-test, it's straightforward. There's not like two-tailed test. So you use a 0.025, 0.05 to work. But for the t-test, because it's a two-tailed test, We divide the alpha by 2, and that will give us what? 0.025 and 9 degrees of freedom. When you read from the T distribution table, it gives you 2.262. This, are we okay? So the decision rule is that reject H naught when T is greater than what? 2.262, or retain H naught when T is less than 2.262. So now how do you compute the T? I will show you on the table. How do you compute the T? Let's go to the table. These are the T values. But unfortunately for you, the T value for the beta 2, the one we are interested in, is omitted. And the examiner intentionally did that because you need it, so you omit it so that you calculate it. So how do you get this value, which is omitted?
Coefficients over standard error.
Good. So the coefficient here divided by this standard error will give you the omitted value. So please divide it for me. This divided by this, what is the answer?
$4.596.
So this is 4.596.
6.
Okay, give into 4 decimal places so that it will tally with what is here.
963.
963. So this is the computed value. Please, do you understand? How did you obtain the T value here? Because we are doing the T statistic for amount of B. Is this divided by this? Will give you this. So that is how I obtain the T value here. Where is it? That's how I obtain the T value here. So it's 1.6280 divided by 0.3542. So when you divide, you get 4.596 to 3 decimal places. To 3 decimal places. Please, are we okay? So the T value is, what's the T value?
4.596.
Good. Is it greater than or less than?
Is greater than.
Greater than.
It's greater than.
Yes, sir.
Good. It's greater than. So because it's greater than, we reject H naught. And rejecting
Yes.
H naught means that the solvent B is predicting significantly, is predicting the Y significantly. So reject H naught at 0.05 level of significance, which means that we conclude that X2 contributes significantly to the prediction of Y. So X2 is contributing significantly to the prediction of Y. That's the meaning. So that is the E. What is F? F is straightforward. F is straightforward. So what is F? If the amount of A changes by 1 unit, state the range of value with which the percentage yield will fall for 95% confidence interval. So this question is straightforward. Shall I show it to you, the answer? Which one are we talking? Is it A or B? Is it X1 or X2 for the F?
X1.
X1. So you go to
Yes.
the main table. Please, are you listening? This is X1. This is a rule for X1. And this is a rule for what? X2. And what they need, the answer is these two answers, 3.0768. What they need is a 95% confidence interval. So you code these two values, that's the answer for the question F. It means what we call the 95% confidence interval. That is to say we are 95% confident that the actual value of the beta 1 lies between what? 3.0768 and 12.5483. So we pick these two values. What are they? So let's go to the answer. I've copied it. So what are the two values there? The confidence interval is 3.0768. That's the lower level, and 12.5483. So the answer is if the amount of A changes by 1 unit, the range of values percentage yield, take the range of value, is it? That makes sense. Value percentage yield takes what? The percentage yield will be between these two values. Have you seen it? Between this and this. That's the answer. Are we okay? Then the last one, the gene. Note is a full question for 20 marks. The gene says what?
What percentage of the total variation in Y can be contributed to the two independent variables?
Okay, so what percentage of the total variation in Y can be attributed to the two independent variables? So how do you get it? Let's go to the table and see whether you can obtain it. That's the value here, which is omitted. So how do you get it?
You square the multiple R.
So that will give us what? Square it. Let me
Okay.
enter it and denote it by a red ink.
Zero point nine two
0.920.
0.920. Yeah.
Okay,
04.
04. Okay, but to
Yeah.
3 decimal places is cool. So 0.920. So that's what we call the coefficient of determination. Alternatively, how can you get that value from here? You divide this one by what? By this. Divide it for me and see. Divide this value by this value.
Zero point 9204.
Have you seen it? So
Yes, please.
either you square this, but if this one is not given, then you can do this divided by this. Are we okay? So it means X1 and X2 are contributing about 92% of the total variation in Y. So that is the answer for the last question. So let's look at the way the solution is done. Oh, I use the quotient, the SSR minus divided by the SST, and that gives us 0.920. That's about 92%. Or you can square the R and will also give you 92.0%. So it means the two factors contribute what? 92% of the total variation in the percentage yield. So that is the answer for the gene. So suppose we bring another question, which is likely to be the case. Find the contribution of other factors apart from the
8%.
8%. That's it. The other factors apart from the X1 and X2 will be 8%. Okay, so this question came last year. So the dependent variables are family issues. What is the dependent variable? The performance of students is a dependent variable. Please, are you with me?
Yes, sir.
Good. Performance of students. So that's what we are predicting, your performance. And according to the question, performance of students depend on 5 variables, which I don't agree with some of them. First, they say family issues can affect your performance. Is it true? Maybe your husband is troubling you at home, so you are not able to study. So it can affect your performance. Is it true? We'll see whether it is so. What about learning environment? Does it affect your performance?
Yes, sir.
What about the student's IQ?
Yes, sir.
Good. Students learning. That's your ability to learn hard.
Yes, sir.
And work issues. Maybe you have some
Same,
problems
sir.
at your workplace, work issues. So we'll see
Yes.
whether these 5 factors, whether they affect significantly the performance of students. So here the dependent variable is what? Is the performance of students. And the independent variables are 5. Family issues, learning environment, students' IQ, student learning. Are you getting me? Then the work issue, 5 of them. That's a lot. So let's go. A says what? What is A?
Write down the estimated model.
Good. So what do you need to write down the estimated model?
You
We
need
to
the
calculate
coefficients.
Coefficient. But unfortunately for us, 2 of them are omitted. For family issue is omitted. So how do we estimate this?
the standard error times T stat.
Good. So this times, multiply it for me and give me the answer. This times this will give us what?
0.516. Sorry.
Good. So that will be the coefficient for family issues. Then this one is also omitted, so we need to compute it. So what will be the answer? It will be this times this, and that will give us what?
Negative 0.22791.
Good. So we'll use some letters to denote family issues, learning environment, student IQ, student learning, and work issues. So what letter should we use to denote family issues?
Yes.
F.
Okay, let me see what, okay, we use P in the solution I did. I used P for performance, F for family issues, LE for learning environment, IQ for students IQ, and S for student learning, and W for work issues. I get it. And because for family issues, the coefficient is not given, we multiply this times this, and that gives us what? 0.516. Is it correct? What you obtain? 0.516.
Yes, sir.
Good. So this place is 0.516. Then we also determine that of work issues. That will be minus 1.222 times 0.187. And that will give us minus 0.229. So it means the estimated model is,
No, the 0.229 is for work issues.
okay, work issue, and the family issue is 0.516. So
Yes,
it will be the constant, then the coefficient times F, the coefficient here times L, the coefficient here times Q, the coefficient here times S, and the coefficient here times W. So this is the model. You pick the coefficient, that's all, to use to write the model. So this is the model. That's for the question A. Then what is the B? Which variables are statistically significant? Which of the variables are statistically significant? So let's work with the table. Which of the variables are statistically significant?
So we'll look for it on the T stat, under the
Yes.
T stat.
So you listen. If you forget, please take your pen and write. What the lady said is correct, but we can also use the p-value to do the same. Some of the p-values are given, like that of family issue, the p-value is given, and this one too, the p-value is given, and the p-value is also given here. Okay, but this and this, the p-values are omitted. So we can use, so like the lady said, so what should be here? You need to write down what is here. What's the answer here? How do you obtain the answer here?
Coefficient over
2.74.
So this divided by this will give you this. Is it correct?
Yes, sir.
Good.
2.74.
So which of these variables are significant? First, determine the critical T value. What will be the critical T value? You compare the T statistic with the critical T value. What is the critical T value? What's the degrees of freedom? It will be 21. For the T test, the degrees of freedom is 21. Please, are you with me?
Yes, sir.
So you read 0.025, 21 degrees of freedom. What is the answer? I want to show you before I go to the solution itself. The value is what? 0.025, 21 degrees of freedom is 2.080. 2.08. So when the T value is greater than 2.08, we say that it is significant. When it is less than, then we say that it is not significant. So which of the T values here? This is too many anyway. If I were to be certain, I'll just pick one of them and you test, like I did with the last year question. I just pick one of them, then you test. This one is requesting that you should test all the 5. So 2.08, this one, is it bigger than 2.08?
Okay.
Is it bigger than 2.08? Family issues?
No,
No,
sir.
sir.
So it means family issue is not significant. It may reject H0. It means when it's less than, it means it is not significant. It means we retain H0. It means it's not significant. The magnitude here is 0.73. It's also less. So learning environment is not significant. Then what about the student's IQ?
2.7486.
That one is greater than, so it is what? Significant. So the student IQ is significant. And the student learning is 2.249, which is greater than. So this is also significant. So student IQ and student learning are significant, but family issue, learning environment, and work issue does not contribute in the predicting student performance. So there are only 2 factors that predict significantly to the performance of student. That is student IQ and student learning. So that is the conclusion that is drawn for this question. So it is answered nicely here. Okay, if IQ changes by a unit, what range of value can student performance take? It's only the 95% confidence interval. What's the 95% confidence interval for IQ? Is this? Please, have you seen it? So the answer for that question is the 95% confidence interval. The lower limit is this and the upper limit is this. So that's the answer for the C. So let's see. C. So that's it. So you pick the lower limit and the upper limit. So that becomes your answer. That is called a 95% confidence interval. That's for the C. So the D says what? The D, what contribution of the 5 factors? What is the contribution of the 5 factors to the change in performance of students? So that will be the R squared. Is it given? Okay, R is given. So square this, what will be the answer? When you square this value, what is the answer? So the coefficient of determinants, determination is what?
0.9840.
Good. So what it means is that what is the percentage contribution of the 5 factors? Who can state it for me? What's the answer? What is the percentage contribution of the 5 factors in determining performance? 98%, about 98%.
Yes,
So
sir.
the conclusion is that for that question, where are you? About 98.4%. So I told you can also use SSR over SST. That will also give you 98.4%. Either you find the R squared or use SSR divided by SST, as I've done in the solution. So it means the 5 factors contribute about 98.4% of the total variation in performance. Then what is the next one? Is the overall performance of the model statistically significant? So we are what are we testing? The overall significance of the model. What will be H naught? You know the 5 steps. There are 5 of them. So we are testing beta 1 equals to beta 2, equals to beta 3, equals to beta 4, equals to beta 5, equals to 0.
Sir, please, question.
Yes, I'm listening.
Sir, please, here it was not stated to use 0.05, or anytime is not stated, we can use that figure.
Exactly so. Whenever it's not stated, 0.05 is a standard. So when it is not stated, always use 0.05 to work.
Okay, sir.
Great. So is the overall performance of the model statistically significant?
Hello, sir.
Yes.
Sir, can we say that the F distribution table always use 0.05?
Yes, for all the exams that I've seen, because that's the only table they give to you during your exams. So for the F test, most of the time in all the exams asked questions, it's always 0.05. But it could be any other thing, but it's only that table that is given to you in exams. Are we okay?
Yes, sir.
Great. So we are testing the overall significance of the model. So how do you test it? H naught says what? Beta 1 equals to beta 2 equals to beta 3 equals to beta 5. There are 5 independent variables, and they are all equal to 0, as against at least one of them is not equal to 0. So we are testing at 0.05 level of significance. So what's the decision? What will be the degrees of freedom for the F test? Who can tell me? From the table, what will be the degrees of freedom for the F test?
5 and 21.
5 and 21. Are you saying it? So what will be the critical value from the F distribution table? You read 5 and 21. And what will it be? 5 is here. Then 21 is where? 21 is here. So what's the value? 2.68. 2.68. So the critical F value is 2.68. So what will be the decision rule? Reject what? What will be the decision rule? Reject when it is greater than 2.68 or retain when it is less than 2.68. Please follow the format I gave in the last year question when you are solving. The 5 steps given. Follow the 5 steps. Then when you follow, you can score all the marks. So what's the decision rule? Reject when the F value is greater or equal to 2.68 or retain when it is less than 2.68. So what will be the computation? We come to the computation. So you go to the table again and do the computed value of F. So how do you determine the computed value of F? It will be what? The MS for regression divided by MS for residual. So when you divide that, it gives you the computed value for F. Good. So this will be MSR over what? MSE, not MST. It's for the error. So that will be the F value. So the F value here with this over this, which will be equal to 258.804. And because it's greater than 2.68, we reject H0. And rejecting the H0 means that the regression model is significant. The model is statistically significant. Then we have the 19 and 20 question, 19, 20. It's not solved, so you can try it for us as an exercise. Okay, so let's try it as an exercise to present next week.